Okay, so I hope you had a chance to go back and do this. I took um, this one right here and I used the information that was given, the mean and the standard deviation, and I found the three standard deviations on each side. This is for the population. The sample size was only 4, but since the population was normally distributed, we knew that the sample was going to be normally distributed. Don't laugh at my curve. Um, then to find the standard deviation for the sample, you have to use the formula. You take the standard deviation of the population and divide it by the square root of the sample size. So 18 divided by the square root of 4 come out to be 9. And then these are the new numbers. So notice that the 3 standard deviations away from the mean for the sample is a lot shorter than the mean than the 3 standard deviations for the population. So we start and end at 108. So the sample sizes for the sample, they're fitting in right about here. We just used, we squished it together. It just squishes it together is what it does. So, okay, so now that you understand that you have to find your new um, standard deviation, this is the formula that you can use to find Z when you're working with samples. It's basically the exact same formula that we had, but this right here, we don't use that symbol, we use S. I will calculate S, but in case I will calculate S before I find my Z score, and this will be the formula that I use most often right here because I will have already calculated S. But if you want to calculate it all in one move, you take the mean of the sample and you subtract it from no, I'm sorry. They just have really, I just disagree with that. Let me just make this, they, not very nice, are using um, symbols that are extremely confusing. So let me say it again. You're going to take the X value um, of the problem, okay? Take the X value and you're going to subtract that from the mean. And we're talking about the mean of the sample. So we take the X value that we're trying to, calculate the Z value for, and this is the sample mean. And then we're going to divide it by, like I said, the sample standard deviation. This is the sample standard deviation. And I'm going to warn you that you might need to because I'm afraid that this stupid formula where they use confusing symbols might be on what's on the formula sheet. So we might need to adjust that. So you guys be sure um, and make sure that we fix that or talk about it before we take our next test. So here it says in this figure to the right, the mean distance traveled by drivers each day. So if you're this age, this is your average. If you're this age, this is your average. If you're this age, this is your average. And if you're this age, this is your average. That's what that's telling you. So each age has its own average. It says you randomly select 50 drivers from this. So they're asking us about only to consider this. Okay. What is the probability that the mean distance traveled each day will be between 19? Okay, find the probability that my X value, okay, of my sample, this is the X value of my sample, is between 19.4 and 22.5. Okay, that should tell you exactly what you're going to do. You're going to use StatCrunch, right? You're going to go put those numbers in. But see, what's going to happen is if you're not careful, when you write down this information, you're going to say the mean is 20.7. And then it says, um, assume that the standard deviation is 6.5, but remember, this is the mean of the population. This is the standard deviation of the population. If you go put this and you go put this in StatCrunch, you're not going to get the right answer. You're going to get these values right here for the population, and we want it for a sample because we're dealing with a sample of 50 drivers. So if we're dealing with a sample of 50 drivers, we need to know what X bar is. Now, these two are always the same. And then we need to know what S is. And so S is going to be calculated by 6.5 divided by the square root of 50. So S will have to be calculated, and S comes out to be 0.92. So now when you go to StatCrunch and you type this in, you're going to be sure and use this number right here and this number right here in order to get the right answer. So we're going to go over to StatCrunch, and we're going to do between, because they want between. We're going to do the mean and the mean of the sample, because we're dealing with the sample. This is why it gets confusing, because it doesn't change. It just says mean and standard deviation. You have to know to change. The mean is 20.7, because the mean of the population and the mean of the sample are the same. It said that in the central limit theorem. So 20.7. And the standard deviation, we calculated that. We said 6.5 divided by the square root of 50. That's 0.92. And then we want it to be between 19.4 and 22.5. And we can compute that, and it comes out to be 89% or 89.59, round that up. The rounding on this is for area. We usually do 4 decimal places, 1, 2, 3, 4. So this decimal place right here is what I'm looking for. Look to the number to the right. That's a number that's bigger than 5. So this should round up to a 10. So put the 0 right there and then carry the 1. So the final answer is 8960. Okay, that should be the answer to the question. What is the probability? So the probability was 0.8960. Now, I do want to point out that you don't have to do StatCrunch. I can't imagine why you wouldn't want to. Don't make fun of my curves. The mean is 20.7. The standard deviation is 0.92. I don't really know. I can do, the z-scores 1, 2, 3 over, but I just really want to do, here's 22.5. I know it's beyond 20.7. 19.4 is going to be somewhere over here. And I'm trying to find this area right here. Okay, so if I'm going to do it by hand, then what I'm going to have to do is take these X values and find these Z values. I'm going to have to find a Z value for this one, and I'm going to have to find a Z value for this one so that I can look the Z scores up on the table. And if I look the Z scores up on the table, whether I look up this Z score right here, or whether I look up this one right here, and then I'll be able to calculate the area. I actually have to look them both up. I'll have to look this one up and then look this one up and then subtract the differences to get the area in the middle. So how would I calculate the Z-score? This right here. This is how I calculate the Z-score. I do Z is equal to X minus X bar divided by S. And remember, I told you I would have already had S calculated. So one Z-score is 19.4 minus 20.7 divided by 0.92. I do that math and I get, thought I had it done, I don't. So 19.4 minus 20.7 divided by 0.92. That comes out to be a z-score of negative 1.41. Do the same thing for this one. This z-score is 22.5 minus 20.7 divided by 0.92. And I get 22.5 minus 20.7 divided by 0.92. And I get a z-score of 1.96. So this is 1.96. So now I look up 1.96. I look up the area for 1.96. Let me move this a little bit out of the way. So now I look up area for 1.96 and I subtract away from that, look up area for negative 1.41. So I use my table and look it up. I can find my table. 1.96. My table is way over here. Where's my table? There it is. 1.96. My answer 1.96. So it looks like I've used it before. 1.96 is 0.9750. I don't remember what my other one was. So I'm going to have to scroll back out and find my problem. There it is, right there. Going the wrong way. Negative 1.41. Negative 1.41. Come over here and look up negative 1.41, negative 1.41, 1.41, minus 0.0793. So take those two numbers and subtract them. 0.9750 minus 0.0793, and the answer is 0.8957. 0.8957. They said 57. Desmos said 60. What did I tell you happens when you use the table? What do you get? You get round off errors. Why? This number is rounded off. This number is rounded off. And when you use rounded off numbers to get a calculation, it contains a round off error. So we calculate these two, subtract these two, we get 0.8957. And when we used StatCrunch, we got 0.8960. So StatCrunch is most likely more accurate, but it's close enough that you would not lose points regardless of how you did it. So this answer right here by StatCrunch, or this answer right here, the area was 0.8957. Either way will do it. Now, some of you, I hope, after watching this right here, are saying, I don't ever want to do it like that. I don't care how you know how to do it, but doing it like this at least a couple of times will really make sure you understand, because just because you can use StatCrunch to do this doesn't mean that I'm not going to ask you, to tell me the Z value that corresponds to 19.4. I mean, you still might need to do that, because I won't necessarily ask you this question for every single problem on the test where you have to do everything. I may just ask you, can you calculate the standard deviation of the sample? So you'll have to know that this is what I'm asking you to do. So you You do want to especially draw pictures. Now, I used to harp on drawing pictures, and if we were in a face-to-face class and I was giving you a paper test, you would have to draw a picture on every single problem. I strongly encourage you to draw a picture on every single problem, because this is where you can earn back points. If you like don't get the right answer, you show me your picture and I can definitely give you some partial credit if you can get the picture right. This is what a lot of people score a lot better on test number 3, because they got a lot of extra points. Not extra points, I said that wrong. Because they get a lot of partial credit. And the partial credit comes from them drawing the picture and showing the one standard deviation or the z-score and the x value and all that kind of stuff. So it's important that you practice that. And I love StatCrunch because it makes it super simple, but it also robs you of the opportunity to practice some of this other stuff. I have no idea how far I am in this video, but I'm going to go ahead and stop it.